Hello everyone, today I'll be explaining the concept of threads. So a thread is the basic unit of CPU utilization. A thread consists of 4 parts: thread ID, program counter, register set and stack. Modern processes consist of multiple threads. So threads belonging to the same process share code, data and files with each other. In single threaded programming, a process can only carry out one task at a time. So through one thread it can carry out only one task. But in multi-threaded programming, a single process can carry out multiple tasks at the same time. Parallelly, it can perform multiple tasks. Many modern applications run on multi-threaded programming. Multi-threaded is far more beneficial and utilizes CPU more efficiently than single-threaded programming does. There are 4 benefits for multi-threaded programming. They are responsiveness, resource sharing, economy and scalability. So coming to responsiveness, let's say we have an interactive application. It's a calculator, a normal calculator. Now let us assume we are in a single threaded application. Let's say the user gives a very huge operation, 1 million multiplied by 2 million. Now that's a huge operation. It will take a lot of time to compute. That means while the process is computing, you cannot use the application anymore. Your application will freeze and will only start working after the execution has finished. But if we use a separate thread to run that huge process, we can still continue to use other aspects of the calculator. That's how responsiveness is a key factor in multi-threaded programming. Now coming to resource sharing. Processes can only communicate with each other through shared memory or message passing. Now these two features must be explicitly defined by the programmer. But when it comes to threading, multiple threads of the same process share data and memory by default. So the benefit of shared memory is that an application can have multiple different threads running in the same address space. So that is the key benefit, resource sharing. So now let's talk about economy. Normally in single threaded operating systems, we have one process, and when we need to perform another parallel task, we create another process. Now this method takes too much time. Creating a process and copying the contents of the first process into the second process take too much time. This is not economically feasible. Economy here refers to computation, not money. So it is not feasible to create multiple processes every time we need a new branch of operation. So threads solve this problem. Multi-threading operating system solves this problem as multiple threads of the same process share memory with each other. So this makes it more economical to run processes simultaneously. Now let's talk about scalability. Many of the computers in today's world have multiple cores in their CPU. Now in a single core CPU, the CPU can only execute one thread at a time. But in a multi-core CPU, it can execute multiple threads at the same time. So we can scale these threads into multiple cores of the CPU in order to run processes exponentially faster. So these were the benefits of multi-threading. So far we have talked about threads in the generic sense. But now let us introduce ourselves to two different kind of threads. One is kernel threads and one is user threads. So now we'll be learning about multi-threading models, which basically are the relationship between user threads and kernel threads. So here in the many-to-one model, we have multiple user threads mapped to one kernel thread. We have multiple threads mapped to one kernel thread, and by using thread libraries, programmers make this user thread system very efficient. So till the user level, everything is very efficient. So the disadvantage for the many-to-one model is that we have only one kernel thread. All of these user threads are mapped only to one kernel thread. So this means that processes cannot happen parallelly. They will have to be done in an interleaved manner. So it is not efficiently utilizing multiple cores if there are any of the CPU. So that was the many-to-one model. and why it is disadvantageous. So now coming to the one-to-one model, we have a structure that looks something like this. We have multiple user threads and multiple kernel threads, and one user thread is mapped to only one kernel thread. So this solves the drawback of many-to-one model. In the many-to-one model, multiple threads converged into one kernel thread, and that restricted concurrent execution of processes. But this solves the problem as we have multiple kernel threads and we can solve processes concurrently. This also makes use of multi-core processing systems. But it has only one drawback, and that is the creating of a user thread needs creating of a kernel thread. Now creating a kernel thread might affect the speed of an application. So most of the times in many operating systems there are a limit on the number of kernel threads you may create. So this negatively impacts the application or web application. So that was about the one-to-one model and its drawbacks. Before we go any further, let us recap the shortcomings of the first two models. In the many-to-one model, we could not achieve true concurrency because the processor could only schedule one thread at a time. And in the one-to-one model, we achieve true concurrency, but the programmer is limited to the number of threads he or she can use while making the application. But in the many-to-many model, we solve both of these shortcomings. The user can create as many threads as he wants, and the kernel will allocate equal number or a lesser number of kernel threads to the corresponding user threads. So this solves both the previous shortcomings and makes computation faster and allows for true concurrency. In the many-to-many model, there is one minor variation of this model where multiple user threads can be connected to a less than or equal number of kernel threads, but a separate user thread is bound to one kernel thread only. So this model is known as the two-level model. That was the concept of threads and multi-threading processes. Thank you.